Section 2, Day 3 ends with applications of linear systems. So we're going to learn how we can take linear systems and apply them to real-world problems. So example 1, the number of boys exceeds the number of girls by 20. There are 34 students in all. How many are boys? How many are girls? So the first thing you should do is start by defining your variables and try to make them make sense. I'm going to let B equal the number of boys, which means G equal the number of girls. All right, the first sentence, the number of boys exceeds the number of girls by 20. So I know that the number of boys is the number of girls plus 20. Then it says there are 34 students in all. In all means to add. So if I take the number of boys plus the number of girls, I should get 34 students altogether. Once you have the system, I probably think that's the hardest part of these. You have to decide what kind of way you want to solve them. And to be honest with you, graphing is probably not an option. The numbers are large and they're not guaranteed to be pretty. So choose substitution or elimination. In this one, I'm actually going to choose substitution because this top variable is already solved for B. So I'm going to take that G plus 20 and put it in for B. I get G plus 20 instead of the B, and then recopy the rest. Plus G equals 34. And then we solve. G plus G is 2G plus 20 equals 34. Subtract 20 from both sides. Get 2G equals 14. Divide by 2. We get G equals 7. They want to know how many are boys, how many are girls. So I'm going to start with that. There are 7 girls. Then we need to find a place to put that 7 in to get the number of boys back out. And this one right here looks great because it's already solved for B. The number of boys is the number of girls, 7 plus 20. So there are 27 boys. 27 boys, 7 girls. Number 2, adult tickets cost $5 and children tickets cost $2. The total cost for the tickets is $660. If there were 210 people attending the trip, how many were adults? How many were children? If you're confused as to what the variable is, take a look at the sentence that has the question mark. They want to know how many adults, how many children. So let's let A equal the number of adults, which means C will equal the number of children. All right, adult tickets cost $5 each. I know that the word each isn't there, but it's sometimes easier to understand. Each implies multiply. $5 for each adult means 5A. And children cost $2 each, so 2C. The total cost, added up, for the tickets was $660. That equation I just wrote, that talks about money, the quality or the quantity of money. Then it says there are 210 people attending the trip. That means that the number of adults plus the number of children should be 210. And that's the system. Now, this one's set up for elimination or substitution. I'm going to actually choose to eliminate on this one and multiply this bottom equation by -2 so that the C's cancel. And rewrite it. The top equation will say 5A plus 2C equals 660. The bottom equation becomes -2A minus 2C equals -420. Double check to make sure that the variable you intended to cancel actually does, and this one does. The C's cancel. 5A minus 2A is 3A, and 660 minus 420 is 240. If I divide by 3, I find A equals 80. I'm going to put a label on that right away so I don't forget. There are 80 adults. And we're stuck finding the number of children yet, so you have to put that somewhere to get the number of children out. So I tend to look for equations that are both positive and small, and I really like this one right here. So if I put an A right here for, or an 80 right here for A, subtracting 80 from both sides gives me C equals 130. And throw a label on it so you don't forget. Children. All right, Mike had $3.20. If he had 39 nickels and dimes, how many of each coin did he have? So we're looking for the number of nickels and dimes he had. So let's let n equal number of nickels, which means d will equal the number of dimes. All right, the first sentence. He had $3.20. And this is like the last one when we talked about the number of adults costing this much each and the number of children costing this much each. Well, when we know nickels and dimes, we already know how much they cost. We already know that each nickel is 5 cents. In dollars, that's 0.05. So 0.05 times the number of nickels, 0.10 for the number of dimes because they're 10 cents. Together, that should give Mike the 3.2 that he says he has. Keep everything in terms of dollars. I know that he had 39 nickels and dimes, so I know that the number of nickels plus the number of dimes would equal 39. So, solving this one. Elimination, not so pretty. I don't really want to deal with decimals in terms of multiplying, so I'm actually going to take this bottom equation, subtract d from both sides, get n equals 39 minus d, and then take that 39 minus d, put it into the top equation. So I got 0.05, and then instead of n, throw the 39 minus d, and then finish the equation. Plus 0.1d equals 3.2. So now we're going to distribute the 0.05. 0.05 times 39 is 1.95. And 0.05 times a negative d is negative 0.05d. Recopy the rest. I'm going to combine like terms next. So on the 1.95 does not have any like terms to combine. I don't have to do anything with it. But if I combine the negative 0.05 and the 0.1, I get a positive 0.05d. Decimals galore in this one. Subtract 1.95 from both sides. I end up with 0.05d equals 1.25. And if I divide both sides by 0.05, oops, sorry about that, I get d equals 25. You have to put that d equals 25 somewhere to get an n back out, and I already made a beautiful equation right here. N equals 39 minus d, which is 25. So the number of nickels is 14. Make sure you label them both. I never labeled dimes, so I'm going to go back to that and throw the word dimes on that. The perimeter of a rectangle is 76 centimeters. The length of the rectangle is 2 centimeters more than the width. Find the dimensions of the rectangle. We actually did questions like this before, but we only used one variable. Today I'm going to do them using two. So I have a length and a width. I'm going to let L equal the length and W would equal the width. All right, the perimeter of the rectangle is 76. I'm not sure how much you remember about perimeter, but the formula is 2L plus 2W, and they got 76. The length is, I'm reading the next sentence, the length is 2 centimeters more than the width. This one's way easier to do substitution. I'm going to take this 2 plus W and throw it in the top equation for L. So 2, and then instead of what I've got, I'm going to put a 2 plus W, and then finish the rest. Plus 2W equals 76. Distributing this 2, I get 4 plus 2W plus 2W equals 76. Combining like terms gives me 4 plus 4W equals 76. Subtracting 4 from both sides gives me 4W equals 72. I'm dividing both sides by 4. I'm running out of room. gives me 13, I believe. 72 divided by 4 is 13. No, it's not. It's 18. Oh my. I need both dimensions, so I'm going to take that width of 18 and put it right here for W. So the length is 2 plus 18, so the length is 20. Now, the label on these is not width and length, it's a dimension, and they're all in centimeters, so I'm going to throw centimeters on this one, and centimeters on this one. All right, last one, number 5. The difference of two numbers is 9. Twice the smaller number is 4 less than the larger number. What are the two numbers? All right, I hear them using the word smaller and larger, so I'm going to let S equal the smaller number, which meant L equals the larger number. First thing they tell me is the difference of two numbers is 9. Okay, so in difference, in subtraction, order matters. And in order for them to have gotten a positive 9 out of a subtraction, the larger number must come first. So the larger minus the smaller is 9. Had that been reversed, had they taken a smaller number and subtracted a larger, they would have gotten a negative 9. So larger has to come first. The second sentence, twice the smaller is 4 less than, tack that on the end, the larger. Remember, anytime we've got something less than, that goes on the end. All right, so let's see. This does not lend itself nicely at this point to anything, so I'm actually going to solve this one by substitution, and I'm going to do that by taking the top equation, and I don't know, I guess I'll solve it for L. So I'm going to take L minus S equals 9 and solve it for L. Start by adding S to both sides. I get L equals 9 plus S, because I can take that 9 plus S and put it in the second equation for L. So 2S equals, and instead of L, I'm going to put 9 plus S, and recopy the minus 4. Combining the like terms on the right, I get 2S equals 5. 9 minus 4 is 5 plus S. And if I get all of the variables, the s's to the left, I get s equals 5. So the smaller number is 5. You have a ton of places where you can put that smaller number to get a larger number back out. I'm going to choose right here. The larger is 9 plus that 5, so the larger is 14. There are no labels on this. Numbers don't get labeled, so I'm just going to put 5, 14. But I do want to point out you cannot put parentheses around them. They are not in ordered pairs.